We're now going to move on to the project, which is a bunch of exercises for module number 3. Let's go ahead and do them all. Again, you should only look at this video once you've attempted the exercises yourself. If we go back to the file system view, there is a solutions notebook that holds the solutions as well. All right, so exercise 1, what is the type of the number 0? Well, it should be an integer. We can just verify it like this with the type function, so it is an int. Exercise 2, what is true raised to the false? This is a very bizarre thing to do, but Python treats these numbers, treats booleans as integers. So true is 1, false is 0. So this is like saying 1 raised to the 0 power. Everything raised to the 0 power is 1. You can verify this same operation like this, and this will be the same thing. Exercise 3, verify that 1e6 and 1 million are equivalent. So we learned how to write floats using this e. So I can do 1e6 like this. That is a million. To verify that it's equivalent, we'll just use the equality comparison operator, two equal signs. And you can actually compare it to an integer. It should evaluate as true. So we can think of, okay, this is 1 million and this is 1 million. Notice I've used underscores here, every third 0, so that I can easily determine what number it is. Okay, exercise 4. Do you think the operation 6 divided by 2 will result in an integer or a float? Use the type function to see if you were correct. What is it? Was it the type you expected? Why do you think it evaluates as that type? Okay, so 6 divided by 2. Well, this is 3. I know that. So 3, maybe you're thinking it should be an integer, but Python will return a float. And the reason it returns a float, I'm going to add a new line here, is that every other division, so let's do something that doesn't evenly divide, so say 17 divided by 4, this will clearly be a float. So the reason Python returns it as a float and not an integer, even though it's just a whole number, so you could make an argument that it should just, the type should be 3. And maybe I should verify that this is in fact a float, but I can see the decimal place, so I know it's a float. But in case you want to verify, you can actually put the operation inside of the type function. It will evaluate this first, so it'll do 6 divided by 2 is 3.0, and it is indeed a float. So again, the reason it chooses to return a float rather than an integer is that all the other divisions, if they are not evenly divided, will also be floats. So this is clearly a float, which means that just to be consistent for all divisions, anytime you divide two integers, you'll always get a float. If you want an integer, you need to use the floor division, which is that symbol, 2 forward slashes, and that will give you an integer. All right, let's do number 5. Write the number 1 million using underscores where commas would normally go. Well, I already did that above there, but let's just do it here again. So that's how you would do it. And I like to use these underscores. It makes it more readable, and I suggest you do the same thing whenever you have larger numbers like this. All right, so that's it for the project for module number 3.